Hi students, this is a question from Ontario Curriculum, Year 11, and what they said in it, a farmer has 540 meter of fencing to enclose a rectangular area and divided into two sections as shown in this figure. And what are we need to find out here? Write an equation to express the total area enclosed as a function of width only. And also they're asking for the domain and the range of the area function, and also we need to determine the dimensions that give the maximum area. Okay, so first of all we will mark some variables here. Let's define some variable. So I'm considering that the length of this fencing is, let's say, L, and the width of it is W. As you can see, if we fence the whole area, so there will be this whole length L, then W, then L, then W, and this is also W. So the total parameter P will be 2L plus 3W, and it is given as 540, that the total fencing is 540. So we can equate the value here. That means 2L plus 3W is equals to 540 meters. And now let's try to calculate the first part of it. In that case, they are asking for the equation of the total area enclosed as the function of width only. As we know that the area enclosed by any rectangular surface, that is length time breadth or length time width, so this will be L times, we can convert, we need to convert it in the W, so let's convert the whole thing in terms of W. Sure, this will be 540 minus 3W, and L will be 540 minus 3W over 2. Let's say this is our equation number 1, and substitute the value of L here in the original function of area. This will be 540 minus 3W over 2 times W. Now A will be, now let's divide it, and after dividing it, this will be 270 minus 1.5 W times W, and the final function looks like 270 W minus 1.5 W square. So this is the required result for part A. Now let's try to solve the part 2. In the part 2, they are asking for the domain and the range of this area function. So for that, we need to draw the graph of this function. And for drawing the graph of it, I am considering this as negative 1.5 W square plus 270 W, and this is a quadratic function, and for drawing the graph of it we need to find out the vertex of that, and let's convert this whole function into the completing square method to calculate the vertices of it. Now I am taking the 1.5 common out from it, so that will be W square minus, and if we divide it, so this will be 180, right? 180 W. Now negative 1.5, to convert this whole thing into the completing square, we need to write this as 2 times 90 times W, and also we have to add and subtract the square of 90, so I'm adding it and subtracting it. Now as you can see, it is a very beautiful equation we got here. W plus negative w minus 90 whole square and negative 9 9 81 0 0. Now we can multiply this negative 1.5 inside this. So this whole function will be 1.5 times w minus 90 whole square, and this became positive, and 180 times negative 1.5, this will be how much? Let's calculate. This will be 12150. 12150 w. Okay, now the whole function of area, we got this. As you can see that clearly, if we need to plot it, let's make it a smaller. I'm putting it down there. Now if this is our graph, as you can see already, the vertex of this function, if this is area versus w, so I'm marking this as area and this is w axis. So vertex of this function will be 90 and 12150. Okay, so the vertex will lie somewhere here. I'm marking it somewhere here. Now this point is 90 and 12150. As you can see, this is negative value here. The value of a is negative, so the parabola will go in the downward direction. So it will go like this. So this 90 will lie in the middle, and this is a symmetric. This function will be symmetric on both the sides. So it will cut this w axis somewhere at 180. 180. So this point is 180. Okay, let's make it more visible. 180. So this point B is 180, this point is O, and this is, let's say, A. As you can see, at this point the area will be maximum. Now let's calculate the domain and the range of it. So domain and the range, from this graph we can easily predict that the domain should be, w should be greater than 0 and w should be less than 180. So this will be the domain of the function, and the range, if it come to the range, so range is for the area, and the area should be less than 12150, and it should be greater than 0, because the maximum area is 1215. So we got the domain and the range of this area function. Now the last part of it, this is part B, this was part A, and let's calculate the C1. Determine the dimensions that give the maximum area. As we know that for the maximum area, the width is already 90. We just need to calculate the length for that. So width is already 90, and for the length we can use our previous expression, this one, as it given in the equation 1. So length will be, I am putting the value of w there, so L will be 540 minus 3 times 90 over 2, and this will be 5 540 minus 270 divided by 2, and how much this is? So this will be 540 minus 270 divided by 2, 135. So this is 135 meters. Length will be 135 meters. We got the dimensions for the maximum area. So this is the solution of this question. Thanks for watching.